All right. Hello, everybody. We are just going to do a quick recap on rules regarding the discriminant. Now, everybody should know what the discriminant is, what the expression actually is, where it's located, where to find it. And by the end of all of this, we should all also know the rules regarding the discriminant. So, what is the discriminant? The word discriminant sounds like the word discriminate. And when you discriminate, you might, have an opinion or an idea or a thought about a group of things, a group of people. And in life, that might not be a very nice thing, but in math, it's helpful because math is math. So in math, we have something called the discriminant, which is the expression under the radical in the quadratic formula. So first thing I'm going to write, I don't know if this is going to be too light, let me know, that's all right, be found, I'll switch pens in a minute, in the capital letters quadratic formula, not a quadratic equation. Remember, I keep separating and differentiating between the two of them. Can be found in the quadratic formula. That pen is terrible, sorry. Under, oh man, I'm not winning with these pens today. All right, I'm grabbing a bunch of markers here. We'll try these. Ooh, actually, I found some good ones. This should be better. Underneath the radical. Now, there was another word for expressions underneath a radical, and that word is more general, and that applies to anything underneath a radical. But when it's specifically under the radical in the quadratic formula, that's when it has the special name discriminant. But does anybody remember the name of the expression under the radical in general? Anybody remember that name? It started with the letter R, and you should have it in your notes.
Radicand.
Good, the radicand. Thank you. So can be found in the quadratic formula, specifically under the radical. ... The radicand. All right, so it is under the radical. It is the radicand, but it is a special situation. Now, the quadratic formula is x equals negative what? X equals negative b plus minus the square root b squared minus 4ac all over 2a. And most specifically, the radicand, which is the discriminant, is this part right over here, b squared minus 4ac. Now, there's three things that can happen with that expression, and that's what we're going to talk about right now. First scenario is that b squared minus 4ac is greater than 0. The next scenario is b squared minus 4ac is equal to 0. And the third is that b squared minus 4ac is less than 0. And each of these situations will have different results. Now, what is a word that we can use to describe numbers that are greater than 0? What is a word that we use to describe those numbers that are greater than 0? Starts with the letter P. What type of numbers are bigger than 0?
Positive.
Yeah, positive. So sometimes people read the expression greater than 0. All right, Jabari, make sure you hit mute again after you answer because it gives a lot of feedback. Greater than 0, and it looks so technical and fancy, but really it's just the mathematical way of saying positive. Equals 0 is just, well, that's what it is then. It's 0. And then, obviously, if greater than 0 is positive, then what's less than 0?
Negative.
Good. good, negative. So those are the three scenarios that we are going to compare right now. Now, let's think of a positive number. Let's say the positive number 10. If this over here, b squared minus 4ac equaled 10, if you went into a calculator and hit square root 10, what number approximately would you get? Would you get like 5 point something? Would you get 100? Would you get 2? What number would you get? Something point something when you did the square root of 10. What would you get? Can anyone tell me? You don't actually have to grab a calculator for this. You could just figure this out using some reasoning. Square root of 10. It's bigger than the square root of 9, but it's smaller than the square root of 16. So you're going to get what number point something?
3.16.
Okay, well, that means you put it in a calculator, young man, doesn't it? So 3 point something if you didn't put it in a calculator, right? Now, does everybody understand the logic I just explained there? Here's 10. 10 is less than 16, right? But 10 is greater than 9. All true. If I take all of their square roots, it's still true. Why did I pick to use 9 and 16 as my two bookends? Why did I pick 9 and 16 to be the bookends around the 10? Why are those helpful?
They're perfect squares.
Good, thank you. Thank you, Dylan, Justin, thank you. They're perfect squares, and the square root of 9 is 3, and the square root of 16 is 4. So since I know those in my head, those are perfect squares, that means the square root of 10, which is not a perfect square, is 3 point, I don't know, something. Who cares? But 3 point something. Great. Okay. Anyway, that means that you're going to take whatever the opposite of b was plus 3 point something divided by whatever that is. And you're going to take whatever negative b is minus 3 point something over whatever 2a is. So how many answers will you get? How many different answers will you get in the case where b squared minus 4ac is some positive number, which you can find the square root of? How many answers do we get? You could just shout it out. Go ahead, Paige. Did you answer? I think you unmuted yourself, but I don't know if I heard you. I feel like it's a little fuzzy, but you get 2 real solutions. Nod if that's what you were saying. Okay, good. Yeah, your sound is like a crackling right now, so maybe some wire's not plugged in too well. 2 real solutions. And that's really because you're doing plus and minus something. So you're going to get 2 answers. And they're real because, like, you can take the square root of it. It's real. When do we get imaginary numbers? Where do they come from? What is I equal to? Who remembers? Because if they're not real, they're going to be imaginary. Where did imaginary numbers come from, Hashar? Do you remember?
I'm pretty sure it was having like a negative number in a square root.
Exactly. If you have a negative in a square root. So a lot of ways I could kind of write that. I'm going to write square root of negative, square root of a negative symbol. I'm going to write it as square root of specifically -1. But yes, that's exactly where the I comes from. It's the square root of a negative. So those are imaginary solutions, I for imaginary. And as long as it's not negative, it's positive. All right. Now, that's what this is right here. If b squared minus 4ac, if this yellow guy right here is less than 0, well, numbers that are less than 0 are to the left of 0 on the number line. Those are negative numbers. Now, Hashar just told us beautifully that that means imaginary. So you're going to have negative b plus some imaginary number divided by whatever that is. And you're going to have negative b minus that imaginary number divided by whatever 2a is. Well, what does that mean at the end of the day? That means you have 2 blank solutions. What do we end up having then? Two imaginary, not real, 2 imaginary solutions. So if we have a negative under the radical, and then we ask ourselves, what number times itself is negative 11? Nothing. That's not real. When you multiply anything by itself, you get positive. So it can't be real. It's imaginary. And then the last case we looked at, b squared minus 4ac is 0. Now, what's the square root of 0? What number times itself equals 0? What's the square root of 0? This is easy peasy lemon squeezy.
0.
Yeah, it's 0. All right. 0 is the only number that if I do negative b plus 0 divided by 2a, and I do negative b minus 0 divided by 2a, I get the same answer. Okay, I get the same exact answer. So if I get negative b plus 0 and minus 0 over 2a, how many answers do I get? How many different numbers is that equal to? Is that 2, 3, 1, 5? How many answers is that?
1.
That's just 1, exactly. So we get 1 real solution. Just 1. And at the very end of our last class, somebody was able to kind of recognize and tell me something about that negative b over 2a that they remembered about negative b over 2a. Where have you seen negative b over 2a before? You could just shout it out. Go ahead, Paige.
It's the x of the vertex.
It is the x of the vertex. Good. So that is pretty nifty information, and I will show you that visually in a minute, okay? So those are some things that we wrote down for our notes for last time, and that's what we needed in order to do our homework for last time, okay? So one other bonus piece of information that I'm going to give you, and I gave to somebody after school last week during extra help office hour, but a bonus piece of information has to do with if b squared minus 4ac equals something called a perfect square. What's a perfect square? What's a perfect square? Who knows? So I'm squeezing that in the corner. If b squared minus 4ac equals a perfect square. What the heck is a perfect square? It's a number. What kind of number? Maybe you could give me an example of what a perfect square is. If b squared minus 4ac equals a perfect square, that means
would like the square root of like 144 or like
good.
Or something like that.
Or what was the other one?
Or the square root of like 64.
Good. Yeah. 144, 64. Perfect. So Hashara just gave us 2 perfect examples of perfect squares. So perfect squares are numbers that have a perfect square root, a nice whole number for a square root. Okay. So 1, 4, 9, 16, 25, so on and so forth, right? So if b squared minus 4ac equals a perfect square, that means the quadratic, this is important and helpful, okay? Squeezing it, but I'm telling you what I'm writing. The quadratic, I'll go like this. All right. The quadratic equation, you can write it bigger yourself, is factorable. So if you ever get stuck on a quadratic and you're like, oh man, is this factorable? I can't find the numbers that multiply or add to give me what I need. Well, if that happens, if you have a hard time getting the numbers that you need, one way to check if it's factorable is just find out what b squared minus 4ac equals. Okay? So, Tanya, are you taking notes though? Like, are you able to do that? I see your message. So it's factorable. So, and if it's not a perfect square, well, that means you have to solve using quadratic formula, but you're almost done anyway. So we're good to go. So we'll talk about that a little bit more visually later. Now, we were requested to go over, so these are the important notes that I want to make sure you guys have down. And then we were requested if we could go over numbers 3 and 4. So that's what I'm going to do right now. I'm going to go over 2 of the questions that you had for homework. So if you happen to do the homework, then this is your opportunity to make corrections to the homework and resubmit it, and I will count the correct one. And if you didn't do the homework, well, if you could at least do the third one, I'm numbering it 3, even though on the paper it says 33 because it was 31, 39, whatever. So 3 was 4x squared plus 20x plus 25 equals 0. And the directions were evaluate. Oh, I'm cut off, right? Evaluate the discriminant, which we just went over what that is, of each equation. I'm just shorthanding the directions. How many solutions? How many real / imaginary? Again, I'm shorthanding exactly what the directions said. Solutions will the equation have? Always read the directions. Write them in your notebook. When you write notes, remember, those aren't just for your hand to get exercise. When you write notes, that's so when you have to do a problem again later, you can compare the directions on the new problem with directions from an old problem. So if you don't write directions, that's kind of silly, right? You're like really hurting yourself in that way. Okay, so we are going to evaluate the discriminant to find out how many real or imaginary solutions there are. So this over here is a quadratic equation. Ax squared plus bx plus c equals 0. That means a equals 4, b equals 20, and c equals 25. The discriminant is, I started writing the whole thing. I don't need the whole thing. B squared minus 4ac. That's our discriminant. We're going to start filling in the pieces. B squared, what do I write down? I'm showing all my work. What do I write down for b squared? I'm not going to get the answer right away. Just tell me what number we write down.
20 to the second.
Good. 20 to the second minus 4 times a times c. And that 4 could also be in parentheses. I just didn't write it right now. And really, I guess this 20 would go in the parentheses. So if it were negative, make sure you put that whole number in the parentheses and then the square on the outside. Okay. From there, what do we fill into those 2 parentheses? What goes in the first one and what goes in the second one?
4 and 25.
4 and 25. Good. Lovely. So I'm going to keep going vertically underneath the problem and show the work that way. So 20 squared. What's 2 squared? What is 2 squared? 4. Now, the 0 at the end, it's not like you do 0 squared, but you're going to do 10 squared. Okay? Here's what's really, this is the trick I'm doing so I don't have to touch a calculator. We're really trying to do 20 squared, right? That's the same as 2 times 10 squared, which is the same as 2 squared times 10 squared. So all this stuff is happening in my head. These are things that will make you better at mental math, okay? So you just said that 2 squared is 4. Now, what is 10 squared?
100.
Good. And if 10 squared is 100, 4 times 100, final answer, 40? 400? 4,000? 400? It's 400, right? Minus, okay. Minus. Now I'm just going to cover that up a smidge. If I write the minus already, I'm going to cover it up, and then I just worry about the signs of these numbers here. To multiply these, I think it's harder to do 4 times 4 first and then the 25. I think it makes more sense to do 25 times 4 because that's a nice number. What's 25 times 4?
100.
Nice. Thank you, Adriana. 100. And then 100 times 4 is 400. And anything minus itself is 0. So if your discriminant for number 3 is equal to 0, how many solutions do we have? Because we evaluated the discriminant. There it is. That is the evaluated, past tense, because we just did it, the evaluated discriminant. This is us doing that process, evaluating the discriminant. Sorry, I'm squeezing it, okay? That's the evaluated discriminant. Now, how many real or imaginary solutions will the equation have? Obviously, that should have had a question mark. There we go. So can anyone tell me what that means? I'm going to put 3 dots in a triangle, which means, therefore, three dots in a triangle like that means therefore. Therefore, there are, you're gonna give me
One real solution.
good, 1 real solution. Boom. Amazing. Okay? So if you got that right, give yourself a high five. Go you. If you got it wrong, that's okay. You're going to get it right next time. It's 1 real solution. Now, just to give you a little peek at exactly what that means. That means in the graph of this function here, of this equation, if I had graphed y equals 4x squared plus 20x plus 25. First of all, do you remember the name of the graph of an equation with x squared in it? What's the name of that graph? It's a quadratic equation, and the graph is called a p-word. What's the name of that graph? Don't be scared. No one's judging you. Starts with the letter P. We graphed a bunch of them. It goes with x squared. This is a quadratic equation, but the graph is called a
Parabola.
Thank you. Parabola. Now, if I graph this parabola, I'm not going to go through the whole process right now. We're going to save that for a little bit later. However, I'm just going to fast forward. If we graph it, the vertex, negative b over 2a, is going to be on the x-axis. And since it's positive, it's going to be opening upward. What do you find when you take an equation for a graph and you set the y value equal to 0? What do you find when you set y equal to 0? If you plug in 0 for y, you find the blanks of the graph. If you set y equal to 0, here's the y-axis. Y equals 0 here. This is where y equals 0. So if you set y equal to 0, you find the blank of your graph. What do you find? What are the points called that touch this? Blank, 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 blanks. 1 syllable and then 3 syllables.
Is it the end behaviors?
Well, end behavior is what we get from like positive 4. That's a good thing to find too. But that would be positive 4. That means it finishes up. And then x squared, it's even. So that means it starts where it finishes, up and up. But, and that's good syllables and behaviors. But X blank blank.
Intercept.
Yeah, X intercepts. Good. It finds us the X intercepts. So by setting that equal to 0, what you're really finding, it's like setting Y equal to 0. You're just sticking it on the right side instead of on the left side. So when they say how many solutions you're finding, you're also finding out how many X intercepts you have. So when it equals 0, that means you have one real solution, and that one real solution is also your one real x-intercept, okay? And then a little thought bubble on the side, if you have two real solutions, your graph might look like that instead. 1, 2 x-intercepts right there. And if your graph has two imaginary solutions, that means no real solutions, maybe your graph looks like that. Look, never crosses the x-axis. So we have a couple different situations that could happen. 2, none, 1. We got the discriminant is 0, which we have in our notes, means one real solution. And a little sidebar, graphically, that means you have one x-intercept. So that's going to be the end of this video. In a separate video, I'm going to go over number 4. So if you want to see another example, that'll be tagged, pop up at the end of the screen. If you feel like you got the hang of this, you'll put a thumbs up on the video. And if you don't, and you're like, this is hard, and you are a crazy person, you'll put a thumbs down on the video. And if you need to see more practice or get another one copied to get more credit for your assignment, make sure you click through to the video at the end and do number 4 along with me.